Okay, so what we're going to do on this, we're going to do number 1 and number 2 on gotta know the facts. Okay? So number 1, it says, what subatomic particle is involved in chemical reactions and determines chemical reactivity? First of all, what are the 3 subatomic particles?
Protons,
Neutrons, and electrons. Okay? Does anybody know which of those 3 is involved in chemical reactions?
Neutron.
Electrons.
Proton.
Okay? And that is for chemical. This whole unit has been about nuclear reactions, which is number 2. Okay? What part of the atom do nuclear reactions deal with?
Protons.
Neutral. Why did I say nucleus?
I need nucleus. That's the answer I'm looking for.
Oh.
Okay? Hold on. We're still talking about subatomic particles, but this is our starting point. So they deal with the nucleus. Okay? Now, what subatomic particles are in the nucleus? Protons and neutrons. That's why there's 2 lines here. So protons and neutrons. Okay? Are we good on those? All right. We're going to skip down to the nuclear facts section. Before we do this, I want to answer the question that's written in the cloud over there, okay? So in the thought bubble, it says, why do nuclear reactions happen? I was not here that day that we wrote this down in our notes, so I wanted to go over with it with you today. They happen to stabilize atoms that have too many protons or neutrons. They happen to stabilize atoms that have too many protons or neutrons. Okay, now, right here, nuclear facts. We're going to circle the true facts about the nucleus of an atom. So we're just worried about the nucleus, okay? I'm not going to do all of them for you, but I will tell you that 1, 2, 3, 4, 5, 6. We need to circle 6 statements, 6 things need to be circled, okay? Now, the ones that I want to look at are at the bottom, okay? Let's start at 7. We're going to go 7 through 10, and I want y'all to tell me which ones are true about the nucleus. Okay, number 7, it contains neutrons and electrons.
Not true.
No, so we're not going to circle that one. Number 8, it makes up nearly all the mass of an atom. Yes. Okay, so I'm just going to circle number 8 here because that's true about the nucleus. Number 9, it is surrounded mostly by unoccupied space. True, okay, because those electrons don't take up much room. And 10, it is encircled by large energy levels containing electrons. True. Okay, so 1 through 7, I need you to circle 3 more things whenever it comes time for you to do this by yourself. Okay? Now, let's look at the fission and fusion section at the bottom. We're going to read these statements and we're going to decide if it's talking about fission or if it's talking about fusion. Okay? Let's do number 2. The supercritical version of this process is utilized in an atomic bomb. Would that be fission or fusion? Fission. Okay, so number 2, I'm going to write FISS for fission. Number 4. Which one is drawn in this diagram? So this diagram I know is black and white on yours, but there's a neutron hitting uranium and then it splits. Lots of energy. What was that? Fission, yes. Number 4 is fission. Number 6 combines nuclei.
Fusion.
Fusion, because they get fused together, okay? F-U-S is how I'm going to write that. And number 8, most commonly used element is hydrogen. That's fusion, okay? Whenever we did our notes over this, we talked about hydrogen's alter ego, deuterium. Okay, so 2 deuterium atoms are the things that get fused together to make helium. Okay, but that is fusion. And number 10 takes place in the sun. Fusion. There's a really bad glare, so whatever. All right, go ahead and turn the page.
The last one was fusion.
Yes. All right, now we're talking about radiation. Okay, alpha, beta, and gamma. Let's see what we got. Which ones did I want to do on this one? Number 2, blocked by paper. Alpha. Number 4, a neutron becomes a proton. We have not talked about this, which is why I wanted to do it. Okay, does anybody want to take a stab at this one?
Beta.
It is beta. Okay, so number 4 is beta, where a neutron becomes a proton. And then let's do number 6, a helium nucleus. Which one looked like helium? Alpha. Okay, I think you can handle the other ones. All right, now we have a true-false section, still talking about radiation. Number 1, we are exposed to radiation all day, every day. True. And number 4, gamma rays usually accompany alpha and beta decay. That is true. We haven't talked about that much either. So anytime you have alpha decay or beta decay, there's normally some sort of gamma rays that are given off as well. All right, symbols for these guys. Anybody remember what alpha looks like? Yep, a weird A. Beta, we're going to put 2 for beta. Okay, so the B has a tail on it. Okay, it has a long tail. It can also be an electron. Oh, alpha can also be helium. And then gamma. It's like a weird, whoa, that's not what I meant to do. It's like a really pretty, like, Y looking thing.
Fancy one.
Yeah, a fancy Y. We have our fancy on. Everybody good here? All right, we're gonna do a little artwork over here on these pieces of material, okay? So I have paper here, aluminum foil, and lead. If I have alpha decay going on, an alpha particle, where is it going to stop?
Paper.
At the paper. So it's going to stop right here. Okay, it gets stopped by paper. Now, if I have beta, what's going to stop it? Aluminum foil. So it's going to go through this paper and stop right here at aluminum foil. And where's gamma going to go?
To the lead.
All the way to the lead. So it's going to go through that, and stop by lead. Just like that. Now, on the test tomorrow, you're not going to have to draw anything, okay? It's all multiple choice and stuff. But if you can just remember what each of those is stopped by, you're going to be in good shape. Okay, what is written in that star on the last page?
Expect throwback questions on the test.
Yes, okay, so throwback questions are anything from a previous unit. All right, so I put a little bit of that on our review today. Okay, I'm going to help you out with some of these, kind of like I did on the circle ones on the true false about the nucleus. All right, we want to circle all of the alkaline earth metals. Now, what group is that on the periodic table?
The second.
The second group. Okay, so group 2. You're going to end up circling 1, 2, 3, 4 things. Okay? I'll tell you 2 of them. Number 9 and number 2. Okay, so you got to get 2 more. Okay? Last little bit, more throwback questions. Number 1, how many valence electrons does the boron group have? So what group is the boron group?
13.
Okay, so it's group 13. So how many valence electrons do they have? 3. Okay, we're just going to take the 1 off right there. All right? I'm going to give you a hint on number 2. Okay? I want to know valence electrons for halogens. What group is that on the periodic table?
17.
Group 17. Okay, so do what you need to about that. And then let's do number 5. What is the least reactive group on the periodic table?
That'd be 18.
Group 18, they're called the what?
Noble gas.
Noble gases. Okay, so on this section of the test, that is still multiple choice, but there are going to be some throwback questions on there, so don't be surprised if you get asked about the periodic table, okay? It is going to be on Canvas like always, okay? So you can use ptable.com for those questions. That doesn't bother me at all right? If you turn this test review in and it's like majority correct, all the ones that we left blank, you do get extra points on that test tomorrow, no matter how you do. Okay, if you make it 100, I'll give you 105. Okay, does that make sense to you guys? The only rule for those extra points is that it has to be turned in before you take the test. I'm not going to take it after the test.
Are you recording?
Okay, I am recording.
Where are you recording?